Okay, so guys, it says use analytic methods to find the local extrema and the intervals of increasing and decreasing. Hey, how do I do that? What should I start doing? Huh? So you would write this as 2x to the what? 2x to the negative 1. So how do we derive that? Or what is the derivative? Negative 2 over x squared. Okay. Critical points. When do critical points occur? When the derivative equals 0 or is this ever going to equal 0? Will it be undefined? When? Okay, so the only critical point I have is x equals 0, yeah? What should I do with that critical point? What? I'm going to do a sign chart. Right? Give me something to the left of 0. Does it really matter? Because when I plug in something on a squared, it's going to become positive. And what's a negative divided by positive? Always a negative. So, but they're both negative, yeah? On either side of 0, this derivative is negative. What does that mean about the function, Turner? You wouldn't know because you're talking. Ben. Hush. I never liked Ben. Okay, guys. So, hey, what's the function doing? I'm sure you said something right now, but it doesn't matter. Doesn't matter. No. Do you feel like you need to? Okay. Alright, so now Ben, you said it meant f is decreasing. Y'all cool with that? So that means f is decreasing, and then something happens and then it decreases more, right? Okay. What is that something that happens? It's a vertical asymptote, right? Now, 2 times 1 over x, same thing is just 1 over x is just vertically stretched a little bit more. Doesn't really matter. You could know this. You could know this function and say, okay, there's not a max or min, right? But if I wanted to prove it, I could use this method. Now, so there are no extrema. What about intervals of increasing? Is f ever increasing? Okay, what about decreasing? So Ben said all real numbers except 0, and then Darren started saying negative infinity is 0, and then 0 to infinity. Are they the same thing? Okay. Either way. Okay, good. So now let's do this function. So 4 minus the square root of x plus 2. And you may not think you do, but you actually know what this function already looks like. How do you know what this function looks like? Because you remember function transformations, right? Perfect. Hey, what's the square root of x look like? What's the square root of 0? What's the square root of 1? What's the square root of 4? What's the square root of 9? Oh, yeah, it looks like that. Like a half a sideways parabola? Yeah? We'll pretend like it went through that point. Okay. So, good thing you all remembered that. Okay, when you add 2 on the inside, where does that mean you go? To the left 2. When you put a negative in the front, what does it do? And then when you add 4, where does it go? So we have a function that actually looks like this. Yeah? And that's an endpoint, yeah? Okay. So I can actually already answer these without using the analytic methods, but I'm going to go ahead and do them to prove that we get the same thing. Because I'm cool like that. Okay, so what do? Take the derivative. So f prime, derivative of 4 is? And what is the derivative of x plus 2 to the 1/2 with a negative in the front? times the derivative of the inside, which is 1. Okay, we good? Alright, does this ever equal 0? No, that fraction will never equal 0, but will it be undefined? When x equals -2. Okay, alright, never mind. Okay, so what are we going to do with that? Perfect, I'm going to do a sign chart. Okay, so sign chart. Give me something less than -2. -3. When I plug that in right there, what happens? What's -3 plus 2? -1. That's imaginary. I mean, we kind of knew that anyway, right? Give me something greater than -2. 0. So if I plug in 0, I get -1 over the square root, -1 over 2 square roots of 2. Is that positive or negative? Okay. So, here's what I know. I know that my function does not exist past -4 and past -2. And then everything past -2, the function is what? I know f is decreasing from there on, right? Which leads me to believe that what happens at -2? Starts, but what would that be? And it would be a it would be a maximum, right? And in fact, it would be the absolute. So let's go ahead and say max at x equals -2, and let's justify y. So how can I justify that I have a max at -2? So first I would say f prime is undefined at x equals -2, which made it be a critical point. And f of -2 is, now the only way that this is an actual point is if this is defined right here, f of -2. So can I plug in -2 into the original? What's -2 plus 2? I'm going to go with 0. I don't even know who said what, but what did I really know? And 4 minus 0 is? Okay, so I actually have a coordinate point, right? Okay, so I have a coordinate point, which means it's not like an asymptote, yeah? Okay, how do I prove that how do I use calculus to say, well, there's a max at the point -2, 4? Well, let's address what's happening on either side of -2. For all x less than -2, f of x does not exist. And for x greater than -2, what? I'm going to say what f prime is doing, and that's why f is doing whatever it's doing. F prime is what? F prime is negative, right? Now the only reason you can say f is decreasing is because you know f prime is negative, but if you don't actually verbalize that f prime is negative, you can't use it. Okay, because you can't use a sign chart as your explanation. Okay, so for all x less than -2, f does not exist, and for all x greater than -2, f prime is negative. Therefore, max of 4 at x equals -2. If for everything past -2 the function is decreasing, then that creates a maximum at the end point. Okay? Okay. Let's do it again. X times the square root of 4 minus x. Alright, what do I want to do? Huh? How do I derive it? Product and chain? Okay, so first, is x times the derivative of the second. What's the derivative of that? Times the derivative of the inside, which is -1. Plus the derivative of the first, what's the derivative of x? Times the second. Okay? So, when I think of that is 4 minus x to the 1/2, the derivative is 1/2, all that to the -1/2 times the derivative of the inside, which is -1. Okay. So I've got negative x over 2 square roots of 4 minus x. Does this one need to have a common denominator? What would the common denominator be? What is square root of 4 minus x times 2 square roots of 4 minus x? 2 times 4 minus x. Because the square roots cancel each other out, right? So I've got negative x, and then I've got plus 8 minus 2x over. Can I combine those now? So what would that be? There you go. That's okay. Okay, so my derivative is 8 minus 3x over 2 square root of 4 minus x, yeah? Alright, so critical points. Critical points are when the numerator and denominator equal 0, right? When does the numerator equal 0? At x equals 8/3. What about the denominator? At 4? So I've got how many critical points? 2? I've got 8/3 and 4. So I'm going to do a what? Sign chart. Which one comes first on the number line, 8/3 or 4? Because it's kind of hard to do a sign chart if you get the numbers right. 8/3. 3 goes into 8 2 times, the 2 remaining, so 2 2/3. So 8/3 comes before 4. Okay, give me something less than 8/3. 0, and I'm plugging them into the derivative, yeah? So 8 minus 3 is positive, and then 4 minus 0 is positive, so positive over positive is positive. Keep in mind that 8/3 is 2 2/3, so something between 8/3 and 4? 3. 8 minus 3 times 3? 8 minus 9 is negative. Is this always positive? It should be, right? 2 times the square root should always be positive, so I'm thinking negative over positive is negative. Give me something past 4. 27 sounds good. What about, if I plug in 27 up here, that's negative. If I plug in 27 down here, what happens? It's imaginary. Does not exist. Okay, so what do I think what do I have? F is increasing, and then it's decreasing, and then it does not exist. So what do I think I have? Maybe a max? Do I have anything else? Maybe a min, if that's an endpoint, right? If it's an asymptote, it's not a minimum, because it doesn't go to a point. But if it goes to a point and it is defined, then that is a point, or that is a minimum, right? So shall I go ahead and plug those in first? What is 8/3 when I plug it in? We're plugging it into what? The original? Yeah, y'all with me? So what is 8/3 times the square root of 4 minus 8/3? Well, 4 is what thirds? 4 is 12/3. What's 12/3 minus 8/3? 4/3. So I've got 8/3 times the square root of 4/3. Square root of 4 is 2. Yeah? So I'm thinking 16 root 3 over 3 over 9. Just kidding. I gotta multiply by square root. Okay. So that is a coordinate point. So do I already know where my maximum is? Yep, that's the max value at that location. We'll prove it in just a second, or we'll verbalize it in just a second. What about f of 4? F of 4 is what? So I'm going to go back to the original. 4 times the square root of 4 minus 4. 4 times the square root of 4 minus 4 is 0. So is it a coordinate point? Does the function exist at 4? Yes? Because it's 0, yeah? Okay, so that means I do have an endpoint, which means it is a minimum, yes? So when I want to verbalize this, how do I say that how do I prove that I have a max or a min or whatever, wherever? At x equals 8/3. What else do we know? I mean, and f prime of 8/3 is 0. So it's proving that we have a critical point there, right? F prime equals 0 and change from positive to negative. Therefore, max of 16 squared to 3 over 9 at x equals 8/3. Now, how would you justify a minimum at 4? Keeping in mind that, guys, when we do this, we're addressing what happens there, and we're addressing the fact that we're addressing either side of it. So, tell me about 4. What's f prime at 4? It's 0 undefined. It's undefined in this one, but that's okay. F prime of 4 is undefined, and what I'm telling them is that makes it a possibility for extrema. And tell me what happens to the left of 4. Okay. So for x between 8/3 and 4, f prime is negative. I don't have to verbalize that that means f is decreasing, as long as I say f prime is negative. And f prime does not exist for x greater than 4, yeah? Meaning we're decreasing and then we stop, right? Okay, so then what happens? So what can I then say? Therefore, we have a of 0 at x equals 4. Okay? Let's see what that function looks like. It actually did that. So that makes sense that we have a maximum here and then a minimum there, wherever it is. Okay. I'm going to zoom in on this a little bit and we'll work part A. Okay. I need you to okay. So it says consider a differentiable function f having domain all positive numbers, all positive real numbers, and for which it is known that f prime of x, so write that down with me. F prime of x equals 4 minus x times x to the negative 3. And this is only for x greater than 0. Okay, it says find the x-coordinate of the critical point of f. Determine whether the point is a relative maximum or relative minimum, or neither for the function f. Justify your answer. Part B says find all intervals in which the graph of f is concave down, which we will do soon. And then given that f of 1 equals 2, determine the function, which we will also do soon. So concavity, we're talking about the shape of the graph, and then that one is telling me, well, I gave you the derivative, can you go backwards and find the original function, which we will do, but not yet. So first it just says find the x-coordinate of the critical point. Well, the critical point is when what? Or critical points occur when? The derivative is undefined or 0. Okay, do I need to take the derivative or do I already have it? I already have it. So I'm going to think of this as 4 minus x over x cubed. So when does that equal 0? That x equals 4. Do I have another critical point? What is it? Why am I not going to write it down? Yeah, because it says x is greater than 0 only, so I don't have to worry about that. And in fact, I know that if x to the third is in the denominator of the derivative, then the original function had x in the denominator, which created an asymptote. So I don't have to worry about it being an extreme. Okay, so what do I need to do? How do I prove that I have a max or min or neither there? Okay, do a sign chart. Give me something less than 4. I don't want to do 0. 1. Okay. 4 minus 1 over 1 cubed, positive or negative? Okay. 5. 4 minus 5 over 5 cubed? Okay. So what do I say? If I were going to justify this on the AP exam, I need to address a few things. The fact that, why do I have a critical point? Because f prime of 4 equals 0. And then why do I know it's a max? Because what is f prime doing? If you say that, go ahead and say between 0 and 4 because you haven't addressed anything past 0, right? But it'd be, in this case, the only reason I did the x is greater than less than on the O is because you have to address the fact that it stops at some point, or it's only from here to there. So here I would just say f prime changes from what to what? At x equals 4, therefore max of, well, actually I can't find the maximum value, can I? Why do I not, why can I not find the maximum value? I don't have the original function. Okay. Okay. One more. Oof. Yes, but there were like 5 that, like, they were all going to be gone for 2 days, and they asked if I video. Okay. It might be a little. Oh, that's fine. Okay. Let f be twice the differentiable function defined in the interval from negative 1.2 to 3.2, with f of 1 equaling 2. The graph of f prime, the derivative of f is shown above. The graph of f prime crosses the x-axis at negative 1 and 3, and has a horizontal tangent at 2. Let g be the function given by g of x equals e to the f of x. Write an equation for the line tangent the graph of g at x equals 1. We could definitely do that. As long as you know. Yeah, you do know that. Let's go ahead and do A. Why not? How do I write a tangent line? Y minus and then equals x minus. Okay, I want to write a tangent line for g at x equals 1. So what goes here? What goes right here? 1. What goes right there? I need to know what? I need to know g of 1. Do I know g of 1? Well, what do I know? So can I find g of 1? What's f of 1? I'm going to go with 2. So e squared? Yeah? Alright, now what goes here? The derivative? So what is g prime? What's the derivative of e to anything? I mean, this is the definition. F prime of x. So if I want to find g prime at 1, what's e to the f of 1? Did we already say that? e squared, right? Times f prime of 1. So I've got e squared times, what's f prime at 1? F prime at 1 is negative 4. So negative 4 e squared. And there's my tangent line. They love to give you functions in terms of other functions and things that, you just have to know what you're doing and you just find each piece where it is. That was fun. Okay, let's do part B. For negative 1.2 to 3.2, find all values x of which the function g has a local maximum. Meaning I want to find my critical points and determine if I have a max, right? Okay. B, so how do I find critical points of g? How do you find the critical points of g? Derive it? Did we already say that g of x equals e to the f of x? So what's g prime? Okay, when does that equal 0? Okay, when you are setting two things, when you're setting two things being multiplied equal to 0, you can separate them and set them individually equal to 0, right? It's called zero product property. Tell me about e to the f of x. What does an exponential function do? Starts here, and then just increases, right? Does it ever equal 0? Not technically. So whenever I see an equation like this, set equal to 0, I just kind of discard that and I say, okay, well, when does f prime equal 0? When does f prime equal 0? Looking at my graph, when does f prime equal 0? Negative 1 and 3. So I've got two critical points. X equals negative 1 and x equals 3. Do a sign chart with f prime. Give me something to the left of negative 1. Negative 2. Okay, when I look at this right here, if I plug in negative 2 into g prime, which is this right here, e to the f of negative 2, what do we say about that? This term is always what? Positive. Things that are being squared are always positive. E, always positive. Square root should always be positive unless there's something going on in front of it. So positive, and then what's f prime at negative 2? Is it positive or negative? Is f prime above or below? It's positive. Give me something between negative 1 and 3. It doesn't really matter. All of it is what? F prime is negative, and then f prime is positive. So when do I have a maximum? When does g have a maximum? I should have said g prime. Negative 1? Why? G prime equals 0 at x equals negative 1 and changed from positive to negative at x equals negative 1, therefore max. Max have what? Do we know that one? We don't know that one. Max at x equals negative 1. Okay. Do you understand a little bit more, or maybe you don't, and maybe you already understood it? But here's hoping that you understand how to justify and what I'm going to be looking for as far as your answers go. Okay? So have you worked on this homework and do you have questions? Or are you still working on mean value theorem homework? Yeah. What are your questions on mean value theorem? Number 9. What's 9 say on mean value theorem homework? That's the function? What's the interval? Okay, so what do I need to do? Okay. Okay, if I plug in 2, I get 4 plus the square root of 4, that's 6. Minus, if I plug in -2, I get 4 over 4, so 1/2. And now I need to what? So 2x plus 1 over 2 square roots of x plus 2. And I want to know when that equals 1/2. Set the derivative equal to the average rate of change. Okay, and did I say no calculator on this one? I said use a calculator. We need to circle that one? Okay. So, grab an 89. William, would you hand me an 89 out of that box down there? Huh? Yeah, I think so. Okay, so how do I solve that? How do I solve that using an 89 really quickly? Alright, grab an 89. If you don't know, grab an 89. Because this is easy and you should know. Check and see if it's over there. It says mean value curve. If it's not, then I'll look for it. Okay, so let's go to F and not. Just write this down real quick and then I'll go find it in a minute because I gotta keep doing it. Well, never mind. Here you go. Okay. Yeah, just put it there. Okay, so I'm trying to solve this equation right here, right? Okay, so where do I go on the 89? F2 and it's just solve, right? So I press enter. Now what am I typing in? The equation? 2x plus 1 divided by, I'm going to put parentheses around because I'm doing multiple things in the denominator. 2 times the square root. Where's the square root? Yep, it's above the multiplication sign, right? Square root of what? X plus 2? Okay, close it. Now, if you would just count the number of parentheses as you do it, you know, like, if you don't know whether or not you should close the parentheses, I open one for the whole thing. This is the denominator, right? This is square root, close the square root, close the denominator, right? I'm trying to solve this equation. You have to actually type in an equation, which means I want to know when this equals what? 1/2, so 1 divided by 2. And I want to solve it for what? I want to solve it for x. So what do I type in at that point? Comma x. So then I do comma x, close parentheses, and press enter. Now, sometimes it takes it a minute and it says busy. That means leave me alone, I'm thinking. I mean, you could start pushing a lot of buttons, but I would just leave it alone. Huh? Yeah, well, there you go. Now, what if your answer is like a big, ugly numerical expression, but it's not decimals? Then you could always just, like, what I would always do. Okay, I need everyone to make sure you pay attention to this. If your answer is you need a decimal and it didn't give you a decimal answer, do not press enter again on this and do diamond enter. I mean, you can. It just takes. It has to think it through all over again. If you just press enter on this and then do diamond enter, it'll just have to convert the answers to decimals. You know what I mean? Instead of having to convert the solution, find the solution and convert to decimals. At this point, you're only doing that. So you got 2 answers, yeah? Are they both answers? Are they both on the interval, -2 to 2? Then those are your 2 answers. -1.988 and 0.077. Okay? Is there another one you need help on? We're good? Alright.